Hello grade 12s, we're going to finish off looking at the question 10s from November 15, which we ran out of time somewhat today. We answered parts A and B of the paper 1. Let's take a look at parts C and D. So we've been given this same graph of the derivative on the second page. This time we can see that we've been given areas A, B and C. Hopefully we're thinking about using some integral calculus, given that we're looking at areas under the curve. You'll notice that A and B are below the x-axis and C is above the x-axis. If we wanted to find the area of A, it should be a positive value, but if we found the integral from 0 to 2, it would be a negative value. That's important when we move on to part C. So we have been given the areas of A, B and C. We've also been given the value of f of 0, and we've been asked to find f of 6. Now, we haven't been given these areas for no reason. This is going to help us answer this problem. And we can find the total area from, the integral from 0 to 6, and use the fundamental theorem of calculus for that. So for part C, we're going to say that if we're going from 0 to 6 of f prime of x, because we've been given the derivative graph, the fundamental theorem of calculus tells us that to find this we would find f of 6 minus f of 0. Switching back to the question, we are given f of 0, so that's this section, we've been given that, we're asked to find f of 6. We need to find another way of expressing this if this is going to be helpful. And the way that we're going to do that is we're going to find the integral from 0 to 6 by using the information in the question. So A is a negative, should be a negative value. So instead of putting 12, I'm going to put negative 12. B is also negative, so I'll put negative 6.75. And C, as it's above the x-axis, is positive, so I'll put positive 6.75. That should be equal to this integral. Then on this side we want f of 6. I think we've been given f of 0 is 14 in the question. So I'm going to take off 14. Okay, so negative 12 equals f of 6 minus 14. So f of 6 is equal to 2. Part D. Let's take a look at that. Okay, part D, we're letting function g equal f of x all squared. So what I notice here is that function g is a composite function. And when I think of composite functions and calculus, I'm thinking of the chain rule. Given that f prime of 6 is 16, find the equation of the tangent to the graph of g at the point where x equals 6. If we want the equation of a tangent, we need to have the slope of the tangent and a point that it goes through. So if I want to find the slope of the tangent, I need to find g prime of x at x equals 6. So to find my slope, I'm going to look for g prime of 6. Now g prime of 6, given our function, is the same as f prime of 6 all squared. Now let's see if that helps us. We're given f prime of 6, so that does help us. So that is 16 squared. 16 squared, yeah. Okay, so for my tangent, I know that my slope is 16 squared, which is 256. So I've got my slope. I now need to find a point. I know the x-coordinate is 6, and I know that I've got this that will help me. In part C, I found f of 6. So to get my point, I'm going to find g of 6, which is f of 6 squared. So I take whatever answer I got from part C and I use it in part D. If I didn't get 2, well, I've got to use what I got and hope that I get some of the follow-through marks. So I got that f of 6 is 2, so I will have 2 squared. So now I have my slope and I have a point. 2 squared obviously is 4. So I've got my point is 6, 4, and my slope is 256. Now we just get our equation of our tangent. So I'll use y minus 4 equals mx minus 6. And I can leave it as that. I haven't been asked to leave it in a certain form. So I would stop at this point.